Okay, good morning students. So before we'll start the exercise, I will tell you two pages I have added later. So for what purpose I have added these two later pages, you can see there some formulas I need to add. For that purpose I have added these pages. Okay, so you can check it out. Work energy theorem. This is the work energy theorem. Okay, basically work energy means two words are given, work and energy, both are equal. Okay, when we will start talking about the work, if you are doing some work, it will be converted into basically energy. That is work energy theorem. So this is the another formula. So when you will apply this formula, that you have to understand where initial and final velocity is given in the work. Okay, one question is there, they will ask, okay, find out the work, and you can't apply force into distance. Why? Because the initial and final velocity is given. So feed into your mind what if initial and final velocity is given, then you will apply this formula. Okay, W is equal to half m into v square minus u square. Okay, now you will be puzzled, okay, so many formulas there, how you can learn it. So I have provided you the table, so you will learn this table. That table is enough. So full chapters formula I have written it here. So what is the table? Because in the chapter only three things are there: work, energy and power. Okay, so see here, work. What is work? In work we are having three formulas. Okay, three formula. What are the formulas? So first of all, F into S, force into displacement. Okay, normal. If angle is given, then F into S into cos theta. If velocities are given, then this formula. Okay, so this is F into S cos theta. This is half m into v square minus u square if velocities are given. Now the SI unit is joule. Now the second, this is all about the work. Now we will come to the energy. Basically when you will think about the energy, the normal formula is W is equal to E. Okay, so if energy they are asking, then you will apply the formula of the work, and the you can say if work and energy are same, then the SI unit is also same. Okay, so in your chapter only two energies are given. Okay, two type of the energy and two type of the formulas. Okay, so mechanical energy is what? Potential energy plus kinetic energy. That's it. Now potential energy formula is mgh, kinetic energy formula is half mv square. Okay, half mv square. Now and basically the unit is same, only the unit is different for the household energy, because some questions are there on the household energy. So you have to learn this formula. Household energy is power into time. Okay, so power into time, kilowatt hour. This will be the unit. If kilowatt hour you will see anywhere, then you will apply this formula. Now we will come to the power. The last one is power. The formula of power is work upon time. Okay, and it is having two units, watt and horsepower, and two unit, two formula: work upon time or force into velocity. Okay, now apart from this, what you have to learn? You have to learn about the conversions. Okay, if more than one unit is given, then you have to learn this. For work we are having two units, joule and erg, and what is the relationship between these two? 1 joule is equal to 10 to power 7 erg. For what purpose I have given this table? So that you can learn all the formulas in this chapter in one table. Okay, so you can make this. Now energy, it is kilowatt hour. Basic energy unit is joule. Bigger unit is kilowatt hour. So 1 kilowatt hour is 3.6 into 10 to power 6. Now power also we are having two units, watt and horsepower. What is the relationship? Horsepower is the bigger unit, it will be equal to 746 watt. Now work, we are having three conditions. This was the units. Now this conditions: if zero work is there, angle will be 90 degree between force and displacement. If positive work is there, the angle will be less than 90 degree. If negative work, then angle will be greater than 90 degree. This was it about the chapter. So learn this table, that will be enough. Why you have to learn? Because you have to secure the marks, that is the thing. Okay, now we'll come to the exercise. Okay, so we are having page number 148. So page number 148, this is the question is force is given 7 Newton. Okay, then displacement is given 8 meter. Then both are in direction of the force. So both are in the same direction. So if same direction is there, the force will be positive. So the work will be positive. Both F and S are in the same direction. Displacement same, force in the same direction. So you will apply work is equal to force into displacement. Okay, now what will be the work in this case? So you will apply the formula. Okay, force into displacement, they are in same direction, so it will be 7 into 8, 56 joule. Now come to the next page, that is 149. So this is the 149 page number. When do you say that work is done? Okay, when do you say the work is done? If force and S in work formula is F into S. If F is there, S is there, then work is done. Okay, now write an expression for work done when force is acting in direction. If it is in direction, then what is this? W is equal to F into S. That is the formula. Okay, now define 1 joule of the work. How will you define 1 joule of the work? What is a 1 joule? Is a unit of work. Okay, work is equal to F into S. Unit of the force is Newton. Okay, you see there? Okay, how they will ask any kind of the unit. How you will define the unit? You have to write down the formula. Okay, they will ask 1 joule. How you will define joule? They are not asking you work. They are asking you unit. Define SI unit. So how you will define it? First write down the formula. Okay, then unit of the, write down units. Okay, 1 joule is equal to 1 Newton into 1 meter. So how you will define it? 1 joule is that work. 1 joule is that work when 1 Newton force is producing 1 displacement, 1 meter displacement. Okay, when 1 Newton force will provide or produce a movement of 1 meter, it is known as 1 joule work. You guys see there, 1 joule is work done when 1 Newton force moves an object by displacement of 1 meter. Now the next question is, if in doubt you can ask me again. Now you can see the force is given in this in question 140 Newton. Okay, and the distance is given. So how much work is there? See, first in this force and distance, while producing the work, you have to check the direction. That's why I have given you the situation. So bullocks are going in this direction, distance is also going in this direction, both are in the same direction, so just multiply them, the simple thing. Okay, so multiply them. You see the bullock and field are in the same direction, so when same direction, work is positive, so multiply this, simple thing. Now the next is page number 152. So this is the page number 152. Okay, this is page number 152. You see there, what is the kinetic energy of the object? Kinetic energy means the energy of the motion. Potential energy means energy of the rest. Now write an expression for the kinetic energy. What is the expression? Half mv square. It means half into mass into velocity ka square. Okay. Now the next one is the kinetic energy. Okay, you have to find out the kinetic energy. No, kinetic energy is given. See, mass is m, velocity is 5, kinetic energy is given 25. They are asking you about if they will. Okay, they have given 2 cases. Okay, they have given 2 cases. First, normally kinetic energy is 25. Now they are asking if they will they will make the velocity double, then how will you, what will be the kinetic energy? Okay, sorry, 3 cases. Okay, first normal case, second double, and third triple. They are making the velocity double and triple. You have to learn the formula only. Okay, the formula is half mv square. Now we can apply. What will happen in case number 1 when the velocity is 2, means double? What will happen in the case number 2 when the velocity is triple? Okay, now see the formula to the question. Okay, now see here. If see, mass of any object is constant. We know that mass is constant. Okay, now if velocity is 2 times, for example, if velocity is 2 times, then what will happen? Kinetic energy is v. Okay, normal kinetic velocity is v. Now they are making velocity 2v. In this case, they are making velocity 3 times. Okay, now the formula is same, half mv square. So only v is given. Only v is given. So what will happen here? Okay, now see here. See, velocity 5, no, velocity 5. This is case number 1, this is case number 2. Okay, so normally the velocity is 5 meter per second. Okay, normal velocity, it is given there. Normal velocity is 5, and normal kinetic energy is 25. We are not making double or triple. Normal one object is there, its velocity is 5, its kinetic energy is 25. Now find out mass. Okay, we will find out the mass. See, kinetic energy V is given, so we will find out the mass. Mass is 2 kg. Because mass was not given, from formula we have calculated the mass, because we will need for case number 1 and 2. Now in case number 1, velocity is double. Okay, so if velocity is double, velocity is 5, 2 times it will become, so it is 10 meter per second. Mass we have calculated already 2 kg. Mass we have calculated already 2 kg. Okay, so now apply the formula. Velocity 10, mass 2, so we will get 100 joule. Simple. In triple also you will apply the same formula. Multiply it with 3 because it has become 3 times. Okay, and you will get the mass. Sorry, you will get the kinetic energy because mass is you have calculated there. Simple. The thing is that you have to apply the formula. Yaar. Just think about, okay, what is given. First read the main important thing is read the statement. Okay, don't be afraid, because yesterday one student asked me, okay, is it from physics? Don't afraid the physics, yaar. In the physics, what is the thing? You have to learn the formula, and for your simplification I have given you the full table. In the table, learn the formula, read the question, what is given in the question, and apply your mind. Your mind application is very important here. So every type of, don't be afraid, just think that all the questions we have solved, the question will come out of these types only. Okay, these types. So in text and exercise, just revise them. Whatever question are coming, as it is we will give. Okay, we will not change the statement. Okay, when you will apply for the competitive examination, if you know the formula, if you know the concept, if you have solved this type of the question, if they will change 5 into 7 and 25 into 27, then also you can apply your mind and the formula. So mind plus formula, you can solve the question. So don't leave any questions, solve every question. Okay, now the next in-text question is the last page, that is 156. See here. Okay, now what is power? Power is the rate of doing work, means W by rate means what? W by T. Divide anything by time, it will become the rate. Okay, if I will write in velocity and I will divide it by time. So what I will say, rate of doing the velocity. Okay, rate of walking, the rate of velocity. Simple. Now define 1 watt of power. It is same like we were defining the 1 joule of work. Same 1 watt means 1 watt is what? What is the SI unit? No. So write down the formula and define it. So how you will define? See, 1 watt I have given in the notes. Okay, so 1 watt is what? Power is equal to work upon time. You just see the notes here. You'll see power is equal to work upon time. Here was the power. I have given the 1 watt. Okay, see there. See here. This is 1 watt definition. Okay, so power is equal to work upon time. So okay, so work is what? Joule. Time is what? Second. So when 1 joule of the work you are doing in 1 second, then it is 1 watt. Simple. So they can ask you the formula, they can ask you the formula, definition of formula or definition of unit. If you know the formula, then you can define anything. Now this is coming the next question, that is 1000 joule. Joule is what? Work or energy. Okay, so work. Okay, now they are saying energy. Okay, see, so what they are doing? Energy. So this is energy. Now a lamp consuming electrical energy. Now 10 seconds. Okay, 10 seconds. So time and energy is given. So what is the power? So energy means work. Okay, so don't confuse that. Okay, energy is given, how I can find out the work? Power is work upon time. First write on the formula. Okay, P is equal to W by T. Now where is W in this? Energy. Energy and work is same. Work will convert into energy. 1000 joule means what? It is work. So 1000 by time, 10, it will become 100. Okay, same. 100 watt. Okay, that's one. Now the next one is average power. So average power, its definition is given at 155 page number. You can see here. Okay, average work. You see here, it is given concept of average power here. Okay, concept of average power. So what is average power? I just told you that total by total. It is total by total. Okay, so how much total energy you are consuming by total time? It is average power. Okay, so energy, in case of energy also you can write down, in case of work is also you can write down, because work is equal to energy. That is the work energy theorem. So you can write average power into energy also, into work also. The same thing we have done in the question number 3. Means we have changed, we have used energy as work. Okay, now summary you will read. Okay, so read the summary at least 2 or 3 times. It will be enough so that you can understand the concept. Now we will come to the this one. What is the exercise? So question number 1, they are asking whether work is done. So work is done means F and S both should be there. Now she's swimming in the pond. So if she's swimming in the pond, first condition, then her body is moving from one place to another place, and she's applying the force by like moving her hands. So F and S both are there, so that's why she is doing the work. Second, a donkey is carrying a load on its back. Okay, so if donkey is carrying a load on its back, the bag is not moving, its body is moving. So in this case displacement is 0, so the work is 0. Now the next one is windmill is lifting the water. So how windmill is working, for that every question, every situation I have made the diagram. Okay, so you can see there, so see there. Okay, so donkey, you see force, or otherwise if you are thinking about the, okay, see in this case always there is upward, and it is displacement is in this direction. So what is there, it is the angle between these two is what, 90 degree. That's why work done is 0, because two situations are there in this, either S can be 0 or 90 degree angle is there. So in two conditions work can be 0. So learn the situation also. Okay, this. Now the next one, windmill, you can see this is the windmill. Okay, so this is the earth. From the earth inside it is like withdrawing the water. Okay, the arrow is in this direction, so it is withdrawing the water. It is a pipe and collecting the water here. Okay, so they are asking that, what they are asking, a windmill is lifting the water from the well. Okay, this is the well, inside the earth it is the well. So the displacement is in this direction, see, in this direction, because water is, it is taking the water in this direction. Okay, it is moving in this direction. Okay, and the force is in circular direction, you see, because who is creating the force, who is like pulling the water from in earth, who is pulling the water, the movement of the blade. So force is in circular direction, so force is in this direction, displacement is in this direction. So it is in upward direction, it is circular direction. So when force, you can't find out what is the angle, but force is also there, displacement is also there, that's why the work is done. Yes, correct. Okay, now the next one is, okay, next one is, this one is next question is, a green plant is carrying photosynthesis. If it is carrying photosynthesis, okay, photosynthesis is happening in the leaf, but it is not like every time when you see the, okay, leaf is there, you will see the leaf. Okay, so you will see the leaf. No, leaf is working. No, leaf is not working. They are asking about photosynthesis, they are not asking about the root. Photosynthesis means the who is doing photosynthesis, leaf. So if you will see leaf is moving, no, leaf is not moving. Leaf is applying the force, no, leaf is not applying the force. Here the water is moving by the root cells. So root cells, through the root cells the water is moving. Who is moving? Water. They are asking about photosynthesis. So leaf is moving, no, leaf is not moving. That's why the work done is 0. In the work done, no, you have to think about which part they are asking. Okay, which part they are asking. If that part is moving, then the work is done. If other parts are moving, no, work is not done. They are asking about photosynthesis. Photosynthesis means leaf. So if leaf is moving, no, leaf is not moving. That's why work is not done. Now the next is engine pulling the train. Engine pulling the train. See, this is the engine. These are the bogies. Okay, so this is the train bogies. This is engine. Engine is moving. Yes, engine is moving. The displacement is there. Yes, it is. These bogies are attached and displacement is in this direction. That's why both are present. So it is, work is done. Next one is food grain dry in the sun. So food grains are on the plate. So sun is there. So food grains are dried. Okay. So force is present. No. Is sun applying any force? No. Are they moving? No. water is moving. Okay, they are asking about food grain, they are not asking about the water. So food grains, is food grain moving, or is food grain doing any work? No, they are not doing any work. Okay, so that's why. The next one is sailboat moves due to the wind. Okay, so you see the wind is applying the force in this direction. Yes, displacement is work moving. This displacement is there, means the boat, the pal. Okay, this is known as a pal in Hindi. In English, okay, means it is like one cloth on the, it is attached on the sail. Yes, it is known as sail. It is known as sail. This cloth is known as sail. So this sail is also moving because air will fill inside this and it will move in this direction. So movement is there, force is there, both are there, then work is done. Yes, it is done. Now the next question. Okay, these are the conditions done. Now the second question is the object is thrown at a certain angle. Object is thrown at a certain angle in the ground in the curved path like this. Okay, this is here, so it is moving in this direction like this. Okay, so it is fall back to the ground. Initial and final path is point is same, means on same ground. So like you are like throwing the ball, you can understand this by the cricket. Okay, cricket, you are throwing the ball. So what is the work done? By force of gravity they are asking. Okay, not by your hand. You are pulling, you are throwing the ball. No, they are not asking about your body, they are asking about what work is done by the earth. Force of gravity, who is applying the force of gravity? Earth. Okay, so first draw the earth. Okay, and then object. Just think about the ball. So you are throwing the ball and ball is going in the curved direction. You see, while you are doing the you are playing the cricket also. So this one, so FG. So last chapter gravitation we have done, gravitation is always in the downward direction and its movement is in this direction. So when it is moving all the time, FG is this. So displacement is in this direction. Ball is moving. Yes, ball is moving. So displacement is in this direction. This, but FG is in this direction. So angle between them is 90 degree. Okay, so if it is 90 degree, then what will happen? See, it is not work done. Work done is 0. Why work done is 0? Because this is displacement. No, we are not talking about, oh, it is in here, so some like here the angle will be different. Okay, then think about the displacement. There is no displacement. No, displacement and F, force and displacement angle. So what is the displacement here? This is the final initial position, this is the final position. Okay, motion chapter. So in between these two, that is the what? This is the displacement S. So between S and FG, what is the angle here? 90 degree. So if the angle is 90 degree, work done is 0. See there, make the diagram. If you are making the diagram in the question, they will give you the more marks. So you have to learn about this in class 10th, because in 10th class you will get the marks if you are making the diagram. That's why I am making the diagram to make you understand. Now next question is coming out, the question number 3. Okay, a battery lights a bulb. Describe the energy changes. What are the energy changes? Think about if you will light the bulb. Okay, so in class 6th and 7th we have understood the electric circuit. What are the components in electric circuit? Wire is there, bulb is there, wire, bulb. Then you are having a switch, because switch on and off. Then the last one is your battery, or you can say the cell. Join two cell, it will become the battery. Okay, so what will happen when current will pass through the wire? What will happen in the cell? Chemical is stored. That chemical will change into the electrical energy and it will start. So chemical will change into electrical energy. It will flow through the wire, come to the bulb. Now you will see the glow is coming out of the bulb, and after some time the bulb will become heated also. It means what? Chemical energy changes into electrical energy, then light energy and heat energy. You are thinking, okay, from where the names are coming? Whatever is the name, no, just add the energy. Chemical was here inside the cell, so add energy, so it will become chemical energy. Electricity will pass, so electrical energy. You will see the light, so light energy. You will feel the heat energy. Simple. Okay, so don't make confuse here. This is what is the thing? Names, no, adding the names. One thing is there, they are just adding the name. See here, this is the chemical inside the cell, so it will change into electrical energy that will start passing here. Okay, then you will see the light, and after some time you will touch, it will become heat. So heat energy and light energy. Simple. Now the next question is, Next question is fourth question. Okay, fourth question is what? Some force is there. Okay, mass is given, velocity, change velocity from this to this. What is this? Initial velocity. What is this? Final velocity. So 5 to 10 means velocity is decreasing. Now they are asking about the work done. So now see, velocity is given, no, and they are asking the work done. So you will apply that formula, the last one, work energy theorem, half m into v square minus u square. So for work we were having three formulas. If normal, f into s. If angle, f into s cos theta. If velocity, half m into v square minus u square. Okay, so this was the formula, half m into v square minus u square. I have written here. Okay, so I will write down here, half m into v square minus u square. That is the formula if velocity is given. Okay, so see here, otherwise you can apply the same formula, but I have given you this one. So apply this formula and you will get the answer, half mv square. Half m is what? 20. What is v square? 2. 2 square means 4. Okay, minus what is 5? 5 5 25. So you just, it will become what? Half into 20 means 10. 10 into 4 minus 25 means 21 minus. Okay, so it will be 210 minus 210 joule. Okay, that one. Negative work means velocity is decreasing. Okay, now next one, the question number 5. Okay, question number 5 is a mass of the 10 kilogram is, mass is given. Okay, so work done, they are asking about gravitational force means by earth what work it is doing. Okay, so think about it. This is the mass. Okay, so you are moving it in this direction it is moving, okay, from a point to b point. Fg always it is in downward direction, and displacement is in this direction, so angle is 90 degree. If 90 degree, no work is 0. You have to write on this one, this much only, simple. Same as question number 2, gravitational force they are asking. No. Now question number 6. Okay, the potential energy of freely falling object decreases. Yeah, it is decreasing because when it is freely falling, it is not having potential energy, it is having kinetic energy. Potential energy slowly becomes kinetic when you are throwing a ball from the upside. Okay, you are throwing a ball. So what will happen when you are throwing the ball? Potential energy changes into kinetic energy. Now they are asking, does it violate the law of conservation? No. Why it will violate here? Conservation of energy means one energy changes into another energy. It will not create energy. One energy already present in the body, it will change into another energy. So when you throw the ball, what will happen? You are holding a ball in your hand. It is potential energy. Now you will throw a ball. What will happen? That potential becomes kinetic energy. So it is like when you are throwing, it is one energy changing into another. No. How it is violating? It is not violating. See what is happening here. The object here, it is having potential energy. Now it will move here, it will become kinetic energy. So one type of energy is changing into another type of energy. So free fall, it will never violate. It will never violate. It will change into the kinetic energy. One energy, another kinetic, another type of energy. Okay. Now the next question is, okay, now they are asking, okay, riding a bicycle. If you are riding a bicycle, what kind of the energy transformation are happening? Okay, so what will happen? Draw the diagram. Yeah, show about your art class. What are you learning in the art class? So I have drawn something. I was like enjoying the drawing, so you can also make that diagram. Okay, yeah, now you see, you are like your hands are on the handle and your legs are on the pedal. Okay, so your body is moving. Yes, your body is moving, force is there. Okay, so in circular motion you are moving your legs, and displacement is there. Yes, from one place to another place your bicycle is moving. Okay, so F is there, S is there. So what is there? Work is doing. Now they are asking what kind of energies are there. You are applying your muscular energy here, your muscles energy. Okay, and this is making kinetic energy of the muscle energy transferring to the body of the bicycle, and it is changing into rotational energy or kinetic energy. So muscle energy changing into kinetic energy.